Good morning, Robert Scribbler. It is May 14th, 2019. Thank you for joining me for another climate change and clean energy video blog. So for this segment, I am going to talk about a new record atmospheric carbon dioxide measure or reading that was recently recorded at the Mauna Loa Observatory in Hawaii in the United States. But before I do, I'd just like to talk briefly about the global distribution of atmospheric carbon dioxide concentration. So if you get close to the northern hemisphere polar region, for a number of reasons, you tend to have heightened levels of atmospheric CO2 at present in the range of 430 million parts per million, 430 parts per million atmospheric equivalent value. And this is due to the fact that a lot of fossil fuel burning infrastructure is located in the northern hemisphere, and also likely due to the fact that carbon feedbacks are ramping up to a certain degree in the Arctic, helping to spike atmospheric carbon dioxide and greenhouse gas values in this region. In the equatorial rainforest region, we have a higher uptake of atmospheric carbon dioxide into vegetative mass, so atmospheric carbon dioxide levels tend to be a bit lower in these regions, around 395 parts per million value at present over the Amazon rainforest region, for example. So you tend to get this variance over the globe with hotspots in certain areas, particularly in areas of high fossil fuel burning or carbon-based feedback hotspot zones, and lower atmospheric carbon dioxide readings in areas where vegetation is taking up more carbon dioxide. Now, at this time of year, the Earth experiences overall a spike in atmospheric carbon dioxide, and this is due to the lag effect of loss of northern hemisphere vegetation during winter. At present, trees are blooming across the northern hemisphere and vegetation is proliferating, but the uptake of carbon dioxide by plants has not yet caught up with the annual loss of vegetative mass and the loss of carbon dioxide uptake. I'm going to go ahead and talk about that cycle a little bit more as we look at the Keeling curve values, but I'm just going to say that one of the reasons why the Mauna Loa Observatory is used is due to the fact that it gets very close to average global atmospheric CO2 levels. This is due to the fact that the observatory is located on a high mountain and also in the middle of the Pacific Ocean, well away from traditional sources or natural sources of CO2. So there's not a large area of, like, for example, a coal plant near the Mauna Loa Observatory, and there's not a large other form of emission there. So the Mauna Loa Observatory is a good place to get an average or close to average atmospheric carbon dioxide reading. Now, carbon dioxide is a major heat trapping gas. In fact, according to NASA, the levels of atmospheric carbon dioxide serve as a global thermostat. So if you look at times in Earth's history, in Earth's deep history, when atmospheric carbon dioxide levels have been high, the Earth system has tended to be warmer. And when atmospheric carbon dioxide levels are lower, the Earth system has tended to be cooler. Now, looking at the recent record high in atmospheric carbon dioxide readings recorded during the past 2 days, we find that atmospheric carbon dioxide levels have hit 415 parts per million and higher in the Mauna Loa Observatory. And I'm just showing you this graphic here to show you how far outside the context of the last 800,000 years present atmospheric carbon dioxide levels are. So up here in the upper right-hand corner of this visual, we see the vertical line in atmospheric carbon dioxide levels spiking up to 415 parts per million. And in the preceding form of the graph, we can see the fluctuation of atmospheric carbon dioxide through the glacial periods with rather low atmospheric carbon dioxide, and the interglacial periods in which carbon dioxide levels increase coordinate with a warming of the Earth system. Now, these periods of glacial periods, ice age, what we call ice age periods, and interglacial periods, has progressed periodically over the last 800,000 years and has extended all the way back, likely to the start of the Pleistocene period more than 1 million years ago. And so at present, what we are seeing is atmospheric carbon dioxide levels that are well outside of the context of not only the last 800,000, but also more than 1 million years ago. And I'm going to talk about that a little bit more. One of the reasons why these atmospheric carbon dioxide readings are so important is because we can actually get a direct measure of carbon dioxide in the atmosphere of past climates running all the way back to 800,000 years by looking at ice cores that have been drilled into the very deep ice sheets in Greenland and Antarctica. And those ice cores contain bubbles of atmosphere trapped during these periods. And this is as far back as we can directly see. But there are other ways to measure atmospheric carbon dioxide through proxy values. And we can get an idea of what past atmospheric carbon dioxide values were over longer periods of time. But the important thing to note is that, at least in this graph, is that atmospheric carbon dioxide levels are significantly above anything that we have seen in the past 800,000 years, with the only other high value showing at around 300 parts per million at around 320, 330,000 years ago during an interglacial period interspersed by 2 ice ages. So at present, atmospheric carbon dioxide values are more than 40% or about 40% higher than the other highest levels seen in the past 800,000 years. So a very severe departure. And this vertical line represents the period of time in which human beings began to engage in the activity of fossil fuel burning. So looking at more recent graphs, I'm just going to go ahead and take a look at the 1700 to the present. And so fossil fuel burning began in the 18th and 19th centuries, but didn't really ramp up until the late 19th century, and in particular the middle 20th century, where we have seen the major increases in atmospheric carbon dioxide and other atmospheric greenhouse gases through the present day. So the primary driver of this massive spike in atmospheric carbon dioxide levels is fossil fuel burning. And these atmospheric carbon dioxide levels are spiking global temperatures. At present, we have a global increase in temperatures since the late 19th century in the range of about 1.1 degrees Celsius. And this is a major increase in temperature. It's starting to cause large-scale ice melt in the Greenland and Antarctic glaciers and other land glaciers around the world. It's pushing major global sea level rise. It's pushing a loss of ocean health in the form of damage to coral reefs and numerous other marine ecosystems. It's causing a spike in severe weather in the form of severe heat waves, severe droughts, severe wildfires, extreme precipitation events, and helping to load the dice for spiking the most intense storms that are now raging across the globe. The climate crisis itself is causing these impacts and other impacts that we are starting to see today, even as atmospheric temperatures range about 1.1 degrees Celsius above the 1880s levels. But If such high atmospheric carbon dioxide levels remain in the atmosphere for a long period of time, an extended period of time, then temperatures will tend to continue to increase, and we will tend to see more climate disruption, more melted glaciers, more extreme weather, and more harm to the Earth's life support system upon which we all rely. Now, unfortunately, we are still increasing atmospheric carbon dioxide levels on an annual basis at a rate between 2 and 3 parts per million per year. And this would push atmospheric CO2 levels up to around 450 parts per million in little more than a decade, which is a rough threshold, something that we don't want to see, but something that unfortunately we are likely to see unless we see a very rapid reduction in fossil fuel burning. At that point, we would tend to lock in more extreme damage from global warming and the climate crisis. And if fossil fuel burning continues beyond the 450 part per million threshold, the damage continues to escalate further, which is one of the reasons why I have advocated so strongly for a clean energy transition. Now, stepping back from that discussion, I'd just like to point out how far along we are due to the fossil fuel burning that we have already committed ourselves to, and that has produced a 415 parts per million atmospheric carbon dioxide level. So one way to look at what our present climate context is, if atmospheric carbon dioxide levels are at 415 parts per million and remain that high, is to look at proxy measures of atmospheric carbon dioxide in past climates. And in order to do that, we look at scientific studies by Holborn et al. And others that give us a range of carbon dioxide levels in millions of year time frames, running all the way back in this graph to more than 40 million years ago. And what we find looking at this compilation of studies in this graphic is that during the Middle Miocene period, atmospheric carbon dioxide levels exceeded 400 parts per million and spiked up to as high as 450, 470, maybe as high as 500 parts per million. And that prior to that period, which occurred about 15 to 17 million years ago, you didn't see atmospheric carbon dioxide levels above 400 parts per million consistently. So in order to get a time period when atmospheric carbon dioxide levels were as high as they are today, you have to go back 15 to 17 million years to reliably find consistent measures that are above 400 parts per million that spike up to the present level of 415 parts per million. Now, the Middle Miocene period included global temperatures that were in the range of 3 to 4 degrees Celsius warmer than 1880s levels. So this implies that if atmospheric carbon dioxide levels remain high for a long period of time, that there will be Earth system feedbacks and changes to the Earth environment that would ultimately result in that level of warming. Now, we don't want to see that, so it's very important that we first halt the damage coming from fossil fuel burning by first reducing and then eliminating fossil fuel emissions to the atmosphere. And one way that we can do this is transition to clean energy rapidly. And then we need to figure out how to pull down those high atmospheric values in order to prevent the long-term warming that is implied by paleoclimate. Now, it doesn't mean that we would see that much warming this century. This would be a multi-century process, but it's still something that is very concerning and something that we really need to think about if we want to have long-term sustainability of modern civilizations. which is one of the reasons why, all these things that we talk about with regards to sustainability and a clean energy transition are so important. So the major takeaway from this is that at present, the atmospheric carbon dioxide context is in the 15 to 17 million year range. In other words, we haven't seen atmospheric carbon dioxide levels this high in likely 15 to 17 million years. Human beings haven't been on the earth for anywhere near that long, so we really have propelled ourselves far out on a limb when it comes to global climate contexts. So major new record in atmospheric carbon dioxide at the Mauna Loa Observatory, yet another milestone in addition of heat trapping gases into the Earth's atmosphere. And to me, this is an ominous mark. I don't like it. And we really, really need to get our act together when it comes to cutting fossil fuel burning, cutting carbon emissions into the Earth's atmosphere, and transitioning to clean energy and a more sustainable society overall. Thank you for joining me, and I'll be chatting with you soon.